Okay, so in this video, we're going to continue talking about chemical equations. Before we do that, we're going to answer a do now question. And so this is going to go back to what we talked about last class, when we talked about coefficients and subscripts for chemical symbols. Okay, so here's the question. In the chemical symbol shown below, and let me just rewrite that in case you can't read that, it's 3H2. It says how many hydrogen atoms are present? Okay, so pause it here and try to answer this do now question on your own. Okay, so remember when we write H2, we're talking about the two hydrogen atoms being bonded together, and they come in groups of two. Okay, so H2, we would have a hydrogen atom, and we would have another hydrogen atom, and they would be bonded together. Okay, and that would actually be a covalent bond because it's a nonmetal and a metal, a nonmetal and a nonmetal. Okay, so they would share a covalent bond. Okay, that's what the 2 represents. So this is one single molecule of H2. The coefficient in front means that we have 3 of those. Okay, so here's the second one. Okay, so hydrogen, hydrogen bonded together, and then we have hydrogen, hydrogen bonded together. Okay, and so if you count, we have 1, 2, 3, 4, 5, 6 hydrogen atoms. Okay, so the answer to the question should be D. Now the 3 in front means that we have 3 hydrogen molecules. Okay, and so each of these groupings is a molecule. So we have 1, 2, 3 molecules. Okay, but each molecule is made up of 2 hydrogen atoms. Okay, so make sure you understand the difference between coefficients and subscripts when you're looking at chemical symbols. Okay, so let's go on in the notes. Okay, so in the last class, we started taking a look at some vocabulary terms, and so we talked about the difference between an atom and a molecule and a compound. Okay, so a molecule is just like a grouping of atoms, and then if you have 2 or more different types of atoms bonded together, then that molecule could be called a compound. And we talked about that last class, and then we also talked about how to write symbols for molecules or compounds using subscripts and coefficients. That's what we just talked about in the do now question. Okay, and then we did some examples, and then we started taking a look at chemical equations. Now, when you're looking at a chemical equation, what you're talking about is you're talking about a shorthand way of writing what's going to happen in a chemical reaction. So for example, what we're looking at here, this chemical equation, we're basically saying that if we mix Na, which is sodium, with Cl2, which is chlorine, then we're going to get sodium chloride, which is table salt. Okay, and so this is just a way of expressing what's going to happen when chemicals react with each other. And then we talked about what a chemical equation looks like and how it's broken down. And so when you're looking at a chemical equation, what you start with on the left side of the equation, those are called the reactants. Okay, so this is what's being mixed together. This is the matter that is present before the reaction takes place. And then when you mix it together, you get this arrow, and that arrow is a yield arrow or produces arrow. And then on the right side of the equation, you have what's called the products. Okay, and so basically you mix the reactants together, and that yields the products. Okay, so in this case, we're mixing C10H8 with 12 O2 molecules, and that's going to produce 10 CO2 molecules plus 4 H2O molecules. Okay, so the reactants are on the left, that's what you start with, and then that's going to produce the products on the right side. Okay, and so that's kind of what we were talking about last class. And then this is just like a visualization of the same thing. You can see that here, if you're a visual person, you can see we have 2 H2 molecules. So this is H2 and this is H2. And when you add that to O2, like a single O2 molecule, that's going to produce, or that's going to yield 2 water molecules, 2 H2O molecules. And again, on the left side, we have the reactants. That's what we start with. And then we have the products. Okay, notice that we're not really like changing the types of atoms, we're just reorganizing them. And so that's why it says right here on the left that chemical reactions involve the reorganization of atoms. Okay, so we still have the same number of atoms from both sides of the equations. We're just kind of rearranging how they're connected with each other, how they bond together. All right, so let's start off with this example. In the chemical equation below, it says to circle the reactants in red and the products in blue. Now, you might not be able to circle in the video, but I want you to write in words where would the reactants be in this equation, and what would the products be in this equation? Okay, so go ahead and enter that question now. Okay, so remember that the reactants are on the left side of the equation. That's what you start with in a chemical reaction. And the products, this is what you produce, this is what you create, is going to be on the right side of the equation. Okay, so hopefully you got that. Okay, so again, we've talked about subscripts before, and you've learned that subscript numbers in a chemical formula represent the number of atoms in one molecule. So for example, when I write C10H8, this is all one molecule, and that molecule is made of 10 carbon atoms and 8 hydrogen atoms, right? Okay, and we've also talked about the coefficient. Okay, this is basically telling how many of each molecule that you have. Remember, when you don't see a number, then you can assume that there is a 1 there. So when I write 12 times O2, that means each molecule has 2 oxygen atoms, and I have 12 of those groupings. Okay, so this is just like a recap. Now, how many atoms do I have in total? Well, that's 24, right? Each molecule comes with 2 oxygen atoms, that's the O2 part, and then I have 12 of them, right? That's 12 molecules. That gives me a total of 24 atoms. So kind of like what we talked about in the do now question. Now, a few units back, we talked about something really important in chemistry, and that is the idea of the conservation of mass or the conservation of matter. And basically, the law of conservation of mass states that you cannot create or destroy matter. You can rearrange it and you can change its form, but you cannot create or destroy matter. And basically what that means is that however many atoms you have on the left side of a equation, that is on the reactant side, you have to have the same number of atoms on the right side of an equation because mass is conserved. Okay, so if we, for example, if we did an experiment with 70 grams of chemicals, then the products would also have to have a mass of 70 grams because mass cannot be created or destroyed. And we've talked about that before in past units. Okay, so in other words, the equation has to be balanced. Okay, so let's see if we can tell whether or not an equation is balanced. And the way we're going to do that is we're going to count the number of atoms on each side of the arrow and compare them. Okay, so you can think of the arrow as kind of like an equal sign, because on the left side of the arrow, you have the atoms you start with, and on the right side, you have the products, those are the atoms you end up with. And according to the conservation of mass, they have to be balanced on both sides. Okay, so for example, on the left side here, on the reactant side, if you count how many atoms we have 2 hydrogen atoms, because we have H2, and then we have 2 oxygen atoms, because we have O2. On the right side, on the product side, notice we have 2 hydrogen atoms, because we have H2, but now we only have 1 oxygen. Okay, so you have to ask yourself, is this equation balanced? In other words, do we have the same number of atoms on both sides of the equation? Do we have 2 hydrogens on both sides? Yes. Do we have 2 oxygens on both sides? No. We have 2 oxygens on the left side and 1 oxygen on the right side. Okay, so in other words, this chemical equation is not balanced. And what that means is that this equation, the way it's written right now, is actually wrong because it's not going to work out the way it's supposed to be. Okay, because we have to have the same number, we have to have the same atoms on both sides of the equation. Okay, so pause there if you need to look at that some more. Okay, so let's take a look at this chemical equation, see if this equation is balanced. Okay, so we're going to count how many atoms we have on both sides of the equation. So on the reactant side, how many hydrogen atoms do we have on the reactant side? Okay, well, we have H2. The H2 molecule has 2 hydrogen atoms, but we have 2 of those. Okay, so we actually have 4 hydrogens on the left side, and then we have 2 oxygens right here. On the other side of the equation, we have 2 H2O molecules. Okay, so each H2O has 2 hydrogens and 1 oxygen. Okay, so if you imagine it like this, we have oxygen and then hydrogen, hydrogen, oxygen, hydrogen, hydrogen, and so we actually have 1, 2, 3, 4 hydrogens and 2 oxygens. Okay, so is this equation balanced? The answer is yes, it is balanced because we have the same atoms on both sides of the equation. Okay, so this is what's called a balanced chemical equation, right? Because we have the same number of atoms on both sides, which is exactly what we are supposed to have. Okay, so pause there if you need to look at that some more. All right, so let's try to answer some questions on our own. And for this, for these examples, all we want to know is the equation balanced, yes or no? Okay, so pause it here and try to answer this question on your own. Is the chemical equation shown below balanced or unbalanced? Okay, so this chemical equation is actually unbalanced. And the reason it's unbalanced is because on the left side, I have 1 magnesium and I have 2 oxygen atoms. Okay, because of this 2 right here. On the other side, I have 1 magnesium and 1 oxygen. Okay, so my magnesium is okay, but obviously I don't have enough oxygens because I should have 2 oxygens instead of 1 oxygen on the right side. Okay, so this equation I would say is an unbalanced equation, which means that this equation in real life is actually not going to work. We would have to balance this equation in order to get it to work, but we're not going to focus on balancing equations right now. Okay, so pause there and make sure you add that to your notes. Okay, so let's try another one. And again, our objective is the same. We want to know, is this equation balanced, yes or no? Okay, so pause it here, try to do this example on your own. Okay, so let's take a look. Let's see how many hydrogens do we have on the left side. Okay, so I see hydrogen right here, and we have 2 hydrogens and no coefficients. Okay, so on the left side we have 2 hydrogen atoms. Okay, and then I count my oxygens. I have 1 oxygen here. I have 3 oxygens here. Okay, so that is 4 oxygens on the left side. And then I have an S. An S is for sulfur. I have 1 sulfur on the left. And now I look at the right side. Okay, I have 2 hydrogens. Okay, so that's okay. I have 1 S, which is 1 sulfur. And then with the oxygens, I have 4 oxygens. Okay, so is this chemical equation balanced or unbalanced? It is balanced. Okay, so in other words, when I mix HO2, H2O, which is water, with SO3, which is something called sulfite, I believe, then I actually get H2SO4, which if I'm not mistaken is actually sulfuric acid, which is quite dangerous. But that's basically what this chemical equation is showing. Okay, so pause it there and make sure you add that to your notes. All right, so that is it as far as balanced chemical equations go. As always, please let me know if you have any questions, and I'll see you guys in the next video.